Now, the centrifugation process is of two types: differential and density gradient centrifugation. Differential centrifugation will be taught by Dr. Amarpreet in another lesson. I will teach you density gradient centrifugation in upcoming lesson. Okay, density gradient centrifugation is again of two types: rate zonal and isopycnic. What is differential centrifugation? In differential centrifugation, you progressively increase the speed of the centrifugation process. When you centrifuge at low speed, what happens? There will be sedimentation of molecules of higher size. Then you take the supernatant and again centrifuge. Then again, if you now see, the sedimentation will be based on the size. Okay, so at low speed the high size particles will sediment. At high speed, now you can separate the low sized particles. Okay, so that is called differential centrifugation. Based on the molecular size, you can separate progressively. Okay, so this differential centrifugation is used in subcellular fractionation. Okay, this again it will be taught by Dr. Amarpreet. Now let us look into the proper care of centrifuge. Any instrument we use in the laboratory, we should take a proper care. What are the proper care? I told you that every rotor has a speed limit. Horizontal rotors you cannot run in a high speed. Most of the centrifuge, even if you increase the speed, they won't take. But still, you should be careful that the rotors have a speed limit. Whenever you are doing centrifugation, you should properly balance the centrifugation tubes, which I will show you in an animation. During centrifugation, there is a chance of liquid spillage inside the centrifuge. That should be avoided. Why? If there is a liquid spillage, during the centrifugation process, there is formation of aerosol. So any laboratory, there will be these aerosols there. These aerosols, they will carry the infectious particles, fungi, bacteria and all in with them. Okay, so if you are centrifuging infectious particles, the aerosol generated will also contain infectious particles. So it is harmful to humans. So that is why, to avoid or minimize the aerosol formation, we have to clean the centrifuge properly. And the refrigerated centrifuges are like refrigerators, right? So when the refrigeration is on, you should keep the centrifuge closed. Otherwise, what is the purpose? It is like opening the door of the refrigerator. Okay, so lids of refrigerated centrifuge should be closed when the instrument is on, and it should be open when the instrument is off. Why? Because it's a refrigerated system. So if you just keep it closed, now there will be water sedimentation. The water will form. So just keep it open so the water will evaporate. Clear? So all refrigerated centrifuges, after usage, properly clean it, then leave it open so that it can dry. And you have to calibrate the centrifuge at specific interval. This will also we will see. Let's see one by one. Now let us discuss how to calibrate centrifuge. To calibrate the centrifuge, an instrument called tachometer is used. Tacho means speed. Okay, so we use laser tachometer. Most centrifuges, look at the image. If you look at the image, you have a clear port in the centrifuge, right? So this clear port is to pass laser light. Okay, so when the laser light is passed through this port, the reflected light is sensed by the sensor in the instrument. So this is based on the principle by which the speed of a bike is measured by traffic police, right? So you pass some wavelength and it will turn back to you and it will tell you the speed. It is the same principle like sonar. Okay, how a bat, it decides the moving objects and all. Okay, it is the same principle, tachometer. So based on this, we can determine the speed of the centrifuge. Okay, the machine may show that the centrifugation speed is 1000 rpm, but it may actually be just 900 rpm. Okay, when a machine goes old, obviously there will be errors. So that is why at specific intervals you have to calibrate your instruments. Okay, this is very, very important when you are dealing with diagnostic procedures and sensitive research procedures and all. Okay, remember this. So today go back and ask, when is the last time you have calibrated your centrifuge? Okay, let's begin with the EDTA tube. All these blood collection tubes, they are all coded. Okay, so the EDTA tube contains ethylene diamine tetraacetate. It is going to chelate calcium. It is an anticoagulant. Okay, so the EDTA tube is used for sample collection for hemogram, that is RBC count, WBC count, platelet count. This is under the hemogram. HbA1c estimation, hemoglobin electrophoresis, all the DNA and RNA isolation. So in research laboratories, you are going to collect blood which is to be used for DNA isolation and RNA isolation. You have to collect in the EDTA tube, otherwise the lavender colored vial. Okay, the tube cap will be in the lavender color. Remember this. And whenever you collect blood in an anticoagulant containing blood collection tube, you should always mix properly. Okay, you should do inversion, and inversion is one complete turn of the wrist. So it is like one complete turn of the wrist, 180 degrees and back. Okay, so that should be properly done. Then only the anticoagulant will mix with the blood. You just collect the blood, you don't mix, there will be improper anticoagulation. Okay, this is a practical point you should remember. There is a blue capped tube which is citrate tube. Citrate is a weak anticoagulant. This is used for estimation of prothrombin time and estimation of erythrocyte sedimentation rate. This is mostly used in the diagnostic laboratories. Here comes the heparin tube. It is containing a green color cap. Heparin is again another anticoagulant. Okay, the heparin comes in two forms. It may be lithium heparin or sodium heparin. So if you collect this blood in sodium heparin tube and do electrolyte estimation, that is estimation of sodium, potassium and all, it is not going to alter the value that much. Remember this. But one thing is, you should not use lithium heparin containing tube for estimation of lithium. Okay, if you want to estimate the lithium in blood, you cannot use the lithium heparin containing anticoagulant tube. Okay, the research use for heparin tube is, you have to collect blood sample for karyotyping in heparin vial. Remember. Now comes the gel tubes. These are the yellow tubes. Yellow tubes, they contain a gel. This gel will form a physical barrier between the serum or plasma and blood cells during centrifugation. Okay, so most of the times when you separate the plasma from the cellular elements, when you pipe it out, there is a possibility that you also pipe it out RBCs and cells. Okay, so to avoid this, they came up with this idea of using a gel. This gel, during centrifugation, it is going to come in between plasma or serum and the cellular elements. So now you can easily take up just the liquid portion, that is the plasma or serum, by pipetting. One disadvantage of this is you cannot recentrifuge this. So most of the times you collect plasma and store in minus 80 degrees Celsius for further use in research laboratories. So at that time you collect the blood in gel tubes. So you can maximally collect the plasma, right? This is the gel tube. Plain vial is again a red vial. Okay, it is similar to your yellow color only. In yellow color you have a gel. In red color you don't have a gel, and there is no anticoagulant also. So once you put the blood, it is going to coagulate because there is no anticoagulant, and you will get what? You will get the serum. Okay, you will get serum. Okay, so to separate serum you will use plain vial. Okay, so serum also can be stored at -80 and it can be used for procedures like ELISA and all. Now comes the grey vial. This grey vial is specially used for estimation of blood glucose. Okay, it is in the diagnostic laboratories for estimation of blood glucose. The grey vial contains sodium fluoride. Fluoride is an inhibitor of glycolytic enzyme enolase. What happens when you collect the blood and you wait for some time, right? Immediately you cannot centrifuge. Okay, so after some time what will happen? The RBCs, platelets, WBCs, they are all going to use glucose. So when you estimate the glucose amount will be low. So to avoid this, we are inhibiting the glycolysis at the level of enolase by using a fluoride. So all glucose estimation vial, the cap color should be grey, remember. So dear friends, I hope you have enjoyed this lesson. Let me summarize what we have learned in this lesson. Blood samples need to be collected in appropriate blood collection tubes and need to be inverted in a specified manner. Centrifugation is the process of separation of particles from a solution according to the size, shape, density and viscosity. There is a formula to convert relative centrifugal field and revolution per minute. So RCF is equal to 1.12 into radius into RPM by 1000 the whole square. Maximum speed during centrifugation is achieved with the fixed angle rotor. Density gradient centrifugation is done using swinging bucket rotor with brakes off. Thank you for visiting SWAYAM and attending the tutorial. Happy learning.